so today we have a special exam revision session. All right. So today basically I'm going to discuss some simple problems based on the first law of thermodynamics, right? So let's start. First law of thermodynamics. All right. All right. So now when considering the concept behind the first law of thermodynamics, right? So there are several definitions, right? So now I will teach you this concept in a very simple format, right? So basically this is the equation, right? So we call it delta U because here this delta denotes the change, the difference, right? Delta U equals delta Q plus delta W. Is that clear, right? First law of thermodynamics. This law is based on the conservation of energy, right? Keep in mind that this law is based on the conservation of energy. Fine. So if I am going to express this in terms of an equation, right? That is delta U equals delta Q plus delta W. So now the next challenge is how can we understand these terms, right? That is the next challenge, all right? So here what is this delta U? This delta U is the change in internal energy. So I will write, what is this? This is the change in internal energy of the system, right? What is delta Q? This delta Q is the heat added to the system, right? What is this? Delta Q, heat added to the system, all right? What is delta W? Work done on the system, right? So here you have to give a special consideration, or in other words, a special attention to the term system. Delta Q, heat added to the system, work done on the system. Or in other words, we can say the work that has been provided to the system, alright? Now the other thing, when we are going to use this equation, we have to keep in mind that we have to consider about the sign, right? Because that sign is very important. If you say delta U, what will be the sign of this delta U? So that is a problem. If you are going to say delta Q, what is the sign of delta Q? If you are going to say delta W, what is the sign of delta W? That's a problem. So I will give you the solution for that. So that means basically, so now just think that there's a particular system, right? And we are going to perform a certain task. Let's say during this task, we are going to perform work so that there is a certain process that takes from state 1 to state 2. Let's call it like that. So then what is the change in internal energy? So generally the term change means the difference, right? What is the difference? So how we are going to calculate the difference? That is always whatever the final value. So difference, right? Difference, or in other words change. So that means always the final value minus the initial value, right? So how can you find the change in internal energy? So that will be U2, final internal energy minus initial internal energy, right? And I hope that is clear, right? Because U1 is the internal energy at the particular state 1 or the original state, and U2 is the internal energy at the final state. this delta U refers to that particular change. Alright. The other thing, now we cannot every time ensure that this change is positive every time, because now if the final value is greater than the original value, then definitely the change is positive, right? But if you are going to consider this equation, you have to consider the direction. So now I will teach you how the direction, can even say the sign, right, of direction, better called sign, right? So let's say how sign, whether positive or negative, how the sign is going to apply to this equation. That means this delta U is positive, right? This delta U will be positive if we add some heat plus we do some work on the system. Alright. So that means the change in internal energy of a system equals to the summation of the heat added to the system and work done on the system. Is that clear? Shall I tell that again? The change in internal energy of a system equals to the heat added to the system plus the work done on the system, right? So that is one format, delta U equals delta Q plus delta W. So this is another format, and there is a second format also. What is the second format? Second format is delta U equals delta Q minus delta W. So in this case, we say, actually, if when students are going to solve problems, they can use any format, whether format 1. The change in internal energy of a system equals to the total heat added to the system minus the work done by the system. Because if you are going to consider the format 2, the second format, that is the heat added to the system minus the work done by the system, right? Because if you are going to consider the format 1, that is the summation, that is the addition of heat added to the system plus work done on the system. If you are going to use the second format, that is the heat added to the system minus the work done by the system. So that is actually common sense, right? If we say plus work done on the system, then definitely it has to be minus work done by the system. So that is fair, right? So the logic is fair. So clear that the change in internal energy of a system equals to the summation of the heat added to the system and the work done on the system. I personally say that this format is better again, because according to this format, delta U equals summation of two things. Because this is easier than remembering the format 2, right? Because delta U equals this plus that, right? Easy to remember, that's what I'm telling, right? So the change in internal energy of a system equals to the total heat added to the system and the work done on the system. So that is the direction. Because now if you are going to use the format 1, so let's call this format 1, delta U, the change in internal energy of a system. Because if I am going to write the change in internal energy of a system delta U, that means definitely this delta U value is a positive value. Is that clear? Because if I am going to write delta U, yes, that's obviously a positive value, considering that delta U equals U2 minus U1, right? Is that clear? So delta U equals heat added to the system plus the work done on the system. Alright? So I hope that concept is clear. So now let's solve some problem, because now when we are going to solve some simple problem, then you will easily understand the concept behind this, right? So It's easy, it's not difficult at all, right? So it's like this, right? So let's consider the very first problem. Calculate the change in internal energy of a system. So now answer to question number 1. Calculate the change in internal energy of a system if 300 joule of heat is added. Alright, so in the problem it says, now let's write with respect to the units, right? Units and the sign, right? Look here. In the problem it clearly mentions 300 joules of heat is added. Heat added. That is positive. What is the value? 300 joules. Then also it mentions system performs a work. Alright, system performs a work. That means we are not going to do a work on the system. And this time actually system is doing a work, right? So we can say work input to the system, right? Because actually in this case the system is performing a work. Clear? So we can say work input to the system will be what? So that will be negative. Why negative? According to this problem, work input to the system is negative because we are not going to input any work. That particular system is doing a work. So work input to the system is negative. System performs 200 joule work. So what is that? Minus 200 joules. I hope that is clear. Why this 300 joule is positive? Yes, because we are going to add 300 joules of heat. So now I promote the first format. So what is the first format? First format tells that change in internal energy of a system is given by the summation of the heat added to the system plus the work input to the system, right? Or in other words, the summation of heat input to the system and the work input to the system, right? Summation or the addition of heat input to the system and work input to the system. So this is the heat input and this is the work input, right? So what is the heat input? 300 joules. What is the work input? Is that positive? No, negative. Minus 200 joules. What is the answer? 300 minus 200, 100 joules. So what is delta U? Delta U is 100 joules, right? So actually what is delta U? That is the final internal energy minus the initial internal energy, right? That means you can say the final internal energy U2, you can say that the final internal energy U2 has what? Increased, right? So you can call it like that, alright? I hope that is clear, right? So that's all about the first problem, right? I hope that is clear, right? So now let's go over the second problem, right? So this is how we are going to solve this type of problem, right? So again, so now we are going to the second problem, alright? Now, again now, what is the equation and the format that we are going to use? So always, like, I prefer the change in internal energy delta U equals heat input to the system delta Q, right? Heat input to the system delta Q plus work input to the system. So that is the format. Is that clear? So now let's carefully read the problem. Calculate the change in internal energy of a system. We have to determine this. If 700 of heat is removed, alright. So what is delta Q? According to our format, delta Q is the heat input. In this problem it mentions 700 joules of heat is removed. So according to this problem, heat is not added, heat is removed, so it is negative. So it will be how much? Minus 700. Simple, right? Second case, 400 joule work done on the system. Alright. What is delta W? According to this format of the equation, delta W is the work input. Right? What is delta W? That's a work input. And 400 joule work done on the system. So we are going to do a work on the system. So according to the problem, work input is positive. What is the value? 400 joules. So let's use this equation. Delta U equals delta Q plus delta W. What is delta Q? Minus 700 plus delta W. What is delta W? So 400. So the answer will be what? What will be the answer? Minus 700 plus 400 will be minus 300 joules. Right? So we can say the final internal energy U2 of the system has reduced, right? So that is why we are getting a negative difference. So what is delta U here? What is the change? Change is negative. So that means in this case the final internal energy value is lesser than the initial internal energy, right? Because in this case the initial internal energy was a higher value than the final internal energy, right? And I hope that problem is clear.